NFT Fusion, created by the Monkeyzoo project. What is NFT Fusion? Section 1. Revolutionizing dynamic NFTs on the Chia blockchain. The world of non-fungible tokens, NFTs, is evolving rapidly, and Monkeyzoo is at the forefront of this revolution with their groundbreaking NFT Fusion technology. Built on the Chia blockchain, this innovative approach to dynamic NFTs is set to transform the way we think about digital assets, gaming, and the metaverse. NFT Fusion is a sophisticated technology developed by the Monkeyzoo project that allows for a trustless and decentralized way for combining, updating, and upgrading NFTs while maintaining on-chain provenance and the non-fungible nature of the source NFTs. This technology leverages the unique features of the Chia blockchain and introduces a new level of flexibility and functionality to NFTs. Think of NFTs being stored inside of other NFTs. Unlocking the power of Fusion. At the heart of Fusion is the implementation of Chia Improvement Proposal 21, known as Chip 21, the NFT Fusion puzzle built on the Chia blockchain. This puzzle, written in Chia Lisp, which is the Chia blockchain's native smart contract language, enables a trustless and decentralized method to combine, update, divide, and upgrade NFTs. The Fusion puzzle operates on Chia's coin set model, which is similar to Bitcoin's UTXO system but more versatile. In this model, every transaction involves spending coins known as immutable objects and creating new ones. This approach allows for parallel operations, better privacy, and more secure smart contracts. This technical marvel is not just another incremental improvement, it's a paradigm shift in how we conceptualize and interact with digital assets. What makes this a true paradigm shift rather than an incremental improvement is threefold. First, it fundamentally transforms NFTs from static, isolated digital assets into dynamic, composable building blocks that maintain their provenance and uniqueness even when combined. Second, unlike existing solutions that require centralized authorities or off-chain oracles to manage modified NFT ownership, Fusion achieves this entirely through on-chain logic, preserving the core decentralized ethos of blockchain technology. Third, it solves the long-standing composability problem that has limited NFT utility across platforms without requiring the destruction of original assets. The result is a revolutionary framework that enables digital assets to evolve, interact, and transform while maintaining their history and opens entirely new possibilities for digital ownership that were previously technologically impossible. A link to the Chip 21 repo on GitHub can be found in the written version of this presentation. Beyond static NFTs. The Fusion Revolution. Traditional NFTs are often criticized for their static nature, and for some use cases this is essential. But as this technology develops and grows, many use cases will require some form of composability. Once minted, an NFT typically remains unchanged, limiting its utility and potential for evolution. Fusion shatters this limitation, introducing a dynamic element to NFTs that opens a world of possibilities and allows for NFTs to keep the underlying non-fungible status while giving them composability. Fusing is to combine multiple NFTs to create new, more complex assets. Updating is the ability to modify existing NFTs to reflect changes or improvements. Divide can be to split a single NFT into multiple components. Upgrading can be used to enhance NFTs with new features or capabilities. These operations are not just theoretical, they're practical on-chain actions that can be performed securely and verifiably. The coin set model, Chia's secret weapon. Underpinning the Fusion puzzle is Chia's coin set model, a sophisticated evolution of Bitcoin's unspent transaction output system, also known as UTXO. In this model, transactions are conceptualized as spending existing coins and creating new ones. This approach offers several advantages, including parallel processing, which allows for multiple transactions to be processed simultaneously, enhancing scalability. and robust smart contracts that gives the immutability of coins and provides a solid foundation for secure, smart contract execution. The Fusion Puzzle, a ChiaLisp masterpiece. Chip 21 is crafted in ChiaLisp, Chia's native smart contract language. This choice of language is no coincidence. ChiaLisp offers a unique blend of simplicity and power, making it ideal for complex operations like Fusion. The puzzle's design enables a trustless and decentralized approach to manipulating NFTs, allowing for fusion, updates, division, and upgrades without relying on centralized authorities. A link to the Chip 21 ChiaLisp repo can be found in the written version of this presentation. Metadata integration, Chip 15. The Fusion process extends Chip 15's off-chain metadata standard with new properties that can be used by display services and allows digital asset data to shape the future of many industries, including gaming and metaverse environments. Security architecture. The reasons for choosing the Chia blockchain to develop this technology are many, and Chip 21 addresses the key security concerns through the implementation of these following points. 1. Ownership proof that requires cryptographic signatures from all input NFTs. 2. Atomic swaps that ensures all-or-nothing peer-to-peer transaction completion. 3. Immutable contracts that means puzzle code is immutable after deployment. 4. DID or decentralized identification that gives verification-mandated authorization when assets are minted. 5. The Chia blockchain uses the BLS signature scheme for validating transactions, which offers capabilities for signature aggregation and provides different security characteristics compared to the ECDSA's signatures used in Ethereum and other EVM-based blockchains. 6. Reorg resistance that gives a 32-block finality threshold. And 7. The Fusion logic is implemented in ChiaLisp, which offers robust validation through its functional programming approach. While not formally verified in the mathematical sense, the code's functional nature and deterministic execution make it amenable to rigorous testing and analysis. End of Section 1. NFT Fusion. Section 2. Implications for the digital ecosystem. The implementation of Fusion is set to revolutionize the space in many ways, and the following examples are not limited. Dynamic gaming assets. Imagine a game where your character is an NFT which can fuse with weapon NFTs, upgrade its abilities, or even split into multiple characters. Fusion makes this possible. Gaming assets could move seamlessly between games and the metaverse while retaining the asset history, potentially transforming the gaming industry. Evolving digital art. Artists can create NFTs that change over time or in response to specific triggers, opening new avenues for interactive and evolving artworks. Flexible metaverse objects. In virtual worlds, objects represented by NFTs can now be more flexible and adaptable, enhancing the user experience and the functionality of digital spaces. Efficient asset management. The ability to fuse, divide, and upgrade NFTs allows for more efficient management of digital assets, potentially streamlining processes in various industries. Think about the real-world art scene tokenizing their artwork in a secure, decentralized manner, and then being able to fractionalize ownership using Fusion technology. Dynamic storytelling and interactive narratives. Fusion technology enables the creation of evolving NFTs that can change based on user interactions or external events. This opens possibilities for dynamic storytelling experiences where characters or plot elements transform over time, creating unique, personalized narratives for each owner. Fusion-powered virtual identities. By combining multiple NFTs representing different aspects of a digital identity, e.g., avatar appearance, skills, achievements, users can create more complex and nuanced virtual personas. These fused identities could seamlessly transition across various metaverse platforms and games, maintaining continuity and accumulated value. Enhanced collaborative creation. Fusion technology facilitates new forms of collaborative art and content creation. Multiple artists could contribute individual elements that are then fused into a single, more valuable collective work. This process could lead to innovative co-creation models and revenue-sharing mechanisms. Adaptive digital fashion. In the realm of digital fashion, fusion technology allows for the creation of digital garments that can adapt to different virtual environments or user preferences. A single fashion NFT could transform its appearance based on the metaverse platform it's being used in or combine with other NFTs to create unique outfit combinations. Cross-platform loyalty programs. Businesses could leverage fusion technology to create more sophisticated loyalty programs. NFTs representing rewards or status levels from different brands could be fused to unlock exclusive cross-brand experiences or benefits, fostering partnerships and enhancing customer engagement. Dynamic real estate and land development. In virtual worlds, fusion technology enables the combination of separate land NFTs to create larger, more complex properties. This could lead to collaborative building projects and the emergence of virtual real estate development firms specializing in fusing and enhancing digital land assets. Evolving collectibles and trading card games. Fusion opens new possibilities for collectibles and digital trading card games. Cards or collectibles could be fused to create more powerful or rare items, adding strategic depth to collecting and trading. This could revolutionize the way digital collectible games are designed and played. Modular and upgradable smart contracts. In the realm of decentralized finance, DeFi, fusion technology could enable the creation of modular smart contracts represented as NFTs. These could be combined or upgraded to create more complex financial instruments, allowing for greater flexibility and innovation in DeFi protocols. In conclusion, by incorporating these additional use cases, the implications of fusion technology for the digital ecosystem become even more far-reaching, promising a future of increased interactivity, collaboration, and value creation across various digital domains. End of Section 2. NFT Fusion. Section 3. Key technical features of NFT Fusion. True on-chain logic. Fusion's ownership validation behavior is governed by on-chain logic in Chia-less puzzles. Puzzles on the Chia blockchain are secure smart contracts. This eliminates reliance on external services, enhancing security and decentralization. At the heart of Fusion is the singleton puzzle. A singleton puzzle is a smart contract that can be embedded into an individual coin. In our case, the coins represent NFTs. The Fusion system relies on a singleton puzzle, a unique coin that cannot be duplicated, which maintains the authorized state of all locked and unlocked NFTs. The puzzle controls the validation of ownership through cryptographic announcements and enforces the rules for all fusion and defusion operations through its Chia-Lisp code. This implementation of Chip 21 represents a paradigm shift in dynamic digital asset design achieved through three key technical innovations. 1. Self-contained state transitions. The Fusion Singleton Chia-Lisp puzzle implements a state management system that governs all transitions between NFT states, using cryptographic announcements, coin spend validation, and lineage proofs to verify ownership and enforce the rules for fusion, defusion, and upgrade operations according to the conditions specified in the puzzle code. 2. Decentralized validation mechanisms. Unlike EVM systems that require external oracles for dynamic updates like Chainlink, NFT Fusion's validation occurs through offer file semantics, which are atomic swaps that enforce transaction atomicity. The singleton pattern guarantees unique state representation, and the coin set model enables parallel state transitions without global storage. This contrasts sharply with EVM's account-based model, where oracles can be vulnerable to centralized oracle manipulation. And 3. Provenance tracking. Fusion maintains provenance through the singleton puzzle's tracking of launcher IDs and coin relationships, validating component NFTs via cryptographic announcements and lineage proofs during fusion and diffusion operations, while leveraging Chip 15's schema.org metadata standard to enable off-chain applications to recognize and display the historical relationships between fused NFTs and their components. Composability. Fusion allows for the creation of complex composable assets. For example, if a gaming character was created as an NFT, it could contain other NFTs representing weapons, skins, or other attributes. This opens exciting possibilities for gaming and metaverse applications. The Fusion system achieves atomic composition through coordinated coin spends controlled by the singleton puzzle, which maintains the relationships between component NFTs by tracking their launcher IDs and current coin state. This verifies asset relationships through cryptographic announcements during all fusion and diffusion operations. Firstly, parent NFTs maintain Merkle proofs of child assets. Secondly, composition events create new coins with embedded ownership graphs. And thirdly, off-chain metadata relationships use schema.org and Chip 15. Gaming implementation, multi-layer asset nesting. A practical example using Monkeyzoo's Fusion Zoo would be a character structure. Layer 0 could be the base character, Layer 1 the armor, Layer 2 a hat, Layer 3 a chest plate, Layer 4 the weapon, and Layer 5 could be an enchantment. Each digital layer represented as an NFT would still allow for independent ownership proofs even when all assets were fused together to create one gaming character. And as each layer is an individual puzzle, the assets will still maintain provenance and any other pre-built smart contracting features like royalty enforcement. Reversibility. One of the most powerful features of Fusion is the ability to diffuse or reverse the fusion process in a fully decentralized manner. This is because only the owner of the asset can reverse the fusion. This means that components contained in the digital asset can be reversed from a fused NFT, providing flexibility and preserving the value of individual components. The reversibility feature in Chip 21 operates through a dual-phase Chia-Lisp puzzle that enables atomic decomposition of fused NFTs. Through coinset ancestry tracking, each fused NFT contains Merkle proofs of its components. Diffusion requires atomic swaps using Chia's offer file system. Offer files are created on the Chia blockchain to represent an action or trade that, when triggered, is a decentralized peer-to-peer atomic swap. A user's wallet creates the diffusion offer, which creates and executes a simultaneous atomic swap. During diffusion, the wallet creates a spend bundle containing the fused NFT's coin spend to the offer mod hash. This creates an ephemeral coin that, when spent with correct announcements and lineage proofs, triggers the singleton puzzle to validate ownership and component history. The singleton then creates puzzle and coin announcements that enable the atomic release of component NFTs to their specified destination puzzle hashes. Secure transaction flow in NFT Fusion. The fusion and diffusion processes utilize Chia's offer system to enable secure peer-to-peer transactions where multiple coin spends are coordinated through puzzle and coin announcements that verify ownership, validate component relationships, and ensure atomic execution where all parts of the transaction either complete successfully or fail entirely. State transition validation. The puzzle verifies diffusion eligibility through ownership proofs of fused NFT and royalty distribution rules. Some features of the diffusion process are: 1. The asset recovery gives the ability of full component recovery. 2. State proofs through Merkle tree history. 3. Royalty enforcement, which is puzzle native. 4. Metadata preservation that is fully retained. And 5. Transaction finality in one block. Upgradability. NFTs can be upgraded or updated while maintaining their provenance. This feature is particularly useful for evolving collectibles or game assets that need to change over time. As a fused NFT can then be fused inside of another NFT, the upgradability of these digital assets become infinite. End of Section 3. NFT Fusion. Section 4. Advantages over EVM-based solutions. Monkeyzoo's fusion technology has been built on the Chia blockchain, which offers several advantages over traditional EVM-based dynamic NFT technologies. These can be summarized with the following fundamentals that the Chia blockchain offer. Scalability. Chia's architecture enables native scalability and could use a technology called Secure the Bag. This technology has the ability to batches transactions. There are also scalability solutions with the potential use of data layer and layer 2 architecture. Blockchain consensus. Ethereum has sacrificed security when moving to proof of stake to make it more energy efficient, where the Chia blockchain has been developed with the highest security whilst using a proof of space and time consensus to make it energy efficient. A good discussion on this topic was discussed by Christoph Peterzak and can be found in a YouTube video conversation about sustainable blockchains. A link to this YouTube video can be found in the written version of this presentation. Cost effectiveness. Transactions on Chia currently cost fractions of a cent compared to the high gas fees often associated with Ethereum. Enhanced security. Chia offers Bitcoin-level security guarantees while using a more energy-efficient consensus mechanism. It combines the battle-tested UTXO model with BLS Signature's 256-bit security versus ECDSA's 128-bit, and a 32-block reorg resistance. True decentralization. The Chia blockchain is considered one of the most decentralized blockchains, with over 50,000 full nodes securing the network. This level of decentralization enhances security and resistance to attacks. Parallel processing. Chia's architecture supports concurrent coin spends versus EVM's sequential execution. Chia's Merkle tree-based state transitions allow for more efficient transaction processing. Formal verification. Chia Lisp logic on Chia can be formally verified, adding an extra layer of security to smart contracts. Sustainability. Chia's proof of space and time consensus mechanism is significantly more energy efficient than traditional proof-of-work systems, making it a more sustainable option for long-term blockchain adoption. It also alleviates the centralizing nature that proof-of-stake consensus mechanisms fall foul of. Trustless peer-to-peer trading. Chia offer files enable direct, trustless trading between parties without the need for intermediaries or centralized exchanges. This system leverages the power of Chia Lisp, Chia's native smart transaction programming language, to create secure and efficient peer-to-peer trades. So what advantages is there to using the Fusion Dynamic NFT standard in Chip 21? The following areas are key to answering this question. Asset recovery. The Fusion puzzle allows for complete asset recovery without the need for oracles or the burning and reminting of assets. Interoperability. Fusion leverages Chip 15 metadata standards and schema.org to enable seamless integration across gaming engines and metaverse platforms. On-chain logic. Unlike many EVM-based dynamic NFTs that rely on off-chain oracles, Monkeyzoo's NFT Fusion technology uses on-chain logic of ownership through Chia Lisp puzzles, eliminating reliance on external services and enhancing security and decentralization. Off-chain logic. Using off-chain schema.org in Chip 15 metadata allows for a global metadata standard that can be adopted for future use cases. Chia's overarching NFT standard. The NFT 1 standard on the Chia blockchain offers many features for creators and owners when it's compared to other blockchain standards. Whenever an individual asset is created or minted, it becomes its own smart contract that is owned by the asset owner and not governed by a centralized smart contract. Licensing. When an NFT is minted, the minter has the ability to add a license file to the asset. This way, whoever owns the asset in the future can easily see if there are rules or stipulations that are to be followed when using the item. On-chain royalties. Building on the back of the Chia NFT 1 standard, Fusion allows for fully on-chain royalties, giving a new guaranteed revenue stream for technologists. On-chain provenance. With ability to embed decentralized identification into each NFT, a creator can guarantee proven provenance without the need of any centralized service. On-chain permanence. The Fusion system builds on Chia's NFT standard, which allows updating the URIs that point to off-chain content, providing flexibility to change content references if needed. Though the actual permanence of the content itself depends on the external storage solutions used rather than being guaranteed by the blockchain. This allows for the data to remain intact throughout future technical advancements. End of Section 4. NFT Fusion, Section 5. The road ahead for Fusion technology. As Chip 21 and Fusion gains traction, we can expect to see a surge of innovative applications leveraging this technology. From advanced gaming ecosystems to sophisticated digital asset management platforms, the possibilities are vast and exciting. The Fusion puzzle represents more than just a technical advancement. It is a fundamental reimagining of what's possible with digital assets. As developers and creators begin to explore its potential, we stand on the brink of a new era in blockchain technology. One where NFTs are no longer static tokens, but dynamic evolving entities capable of reflecting the complexity and fluidity of our digital lives. The future of NFTs is not just about ownership. It's about interaction, evolution, and unlimited potential. And with Fusion, that future is now within reach. As for the Monkeyzoo project, we will continue to develop this technology, making it more efficient and faster as the ecosystem advances. We are conceptually working on a version 2 of this technology that could enable data layer integration to validate metadata layers, plus more in-depth support for pick-and-replace fusion and diffusion. This will deliver even more dynamic capabilities without having to completely diffuse the puzzle every time a minor change is made to a digital asset. Conclusion. Monkeyzoo's fusion technology represents a significant leap forward in the world of digital assets. By combining the security and efficiency of the Chia blockchain with the flexibility and functionality of dynamic NFTs, it opens a world of possibilities for creators, gamers, and collectors alike. As we move towards an increasingly digital future, technologies like Fusion will play a crucial role in shaping how we interact with and value digital assets. The Monkeyzoo project has not only developed an innovative technology, but has also contributed to the broader blockchain ecosystem by implementing and showcasing the potential of Chip 21, Chip 15, and in the future, Chip 35 standards. With its focus on security, scalability, and user experience, Fusion is poised to become a cornerstone of the next generation of NFT applications. As more projects and platforms adopt this technology, we can expect to see a new wave of creative and interactive digital experiences that blur the lines between the physical and digital worlds. The future of NFTs is dynamic, and Monkeyzoo's fusion technology is leading the way. Thank you for watching this presentation about NFT Fusion and Chip 21. If you have any questions about this presentation or fusion technology, you can reach out to the Monkeyzoo team at support@monkeyzoo.net or follow us on X, where we will be happy to answer your questions or help you implement this new technology into your projects. Written by Tim Youngman, founder and CEO of the Monkeyzoo project being built on the Chia blockchain. Dated March 1, 2025.